Today, we're diving into some really cool research that uses lasers to try and fix one of the most annoying problems with the internet.
It's a fair question, right? I mean, you hear all about these global networks of super-fast fiber optic cables, but for most of us, that incredible speed just doesn't seem to make it to our actual building. So what's the deal?
Well, it all comes down to what the experts call the last mile problem. You see, we have these huge fiber highways crisscrossing the country, but connecting your specific office or apartment building to that highway is a whole other beast. It means digging up roads, blocking traffic, it costs a fortune. And that's why a staggering 80 to 90% of commercial buildings still aren't hooked up to the main fiber grid.
So, how do you get over that final hurdle without tearing up the entire city? Well, that's where some clever researchers have been working on a really promising alternative. It's called free space optics, or FSO for short. And the idea behind it is actually pretty simple. Instead of sending light through a glass cable buried in the ground, you just beam it through the air. You're basically creating an invisible fiber optic connection between 2 points. It's a way to get all that speed without any of the digging.
So when you put them side by side, you can see the pros and cons pretty clearly. Fiber is super reliable, but it's a huge expensive pain to install. FSO, on the other hand, is way cheaper and faster to set up, but it has one major Achilles heel: the weather.
And that's the bottom line, straight from the researchers. The biggest enemy of this whole idea is just the air itself. You know, just think about trying to shine a flashlight through really thick fog. The light gets scattered all over the place, and the beam gets super weak. Well, the exact same thing happens to a laser carrying your internet data when it has to travel through heavy rain or haze.
Yeah, this whole weather issue has really been the main roadblock holding FSO back from going mainstream. But that's exactly what this new study is all about, figuring out how to build a laser communication system that can stand up to bad weather. Okay, I know what you're thinking. This diagram looks incredibly complicated, but trust me, the idea behind it is actually really elegant. The researchers basically built a system to pump up not just the speed, but the overall toughness of the connection.
The secret sauce here is something called wavelength division multiplexing, or WDM. The best way to think about it is like this. Imagine the laser beam is a road. WDM takes that single-lane road and turns it into a multi-lane superhighway. It does this by sending data on different colors, or wavelengths of light all at the same time. This system uses 4 lanes, which lets them send a massive amount of data at once.
So, they've built this awesome 4-lane data highway. But here's the billion-dollar question. What happens when a storm rolls in? Does it hold up?
To figure that out, we've first got to understand how engineers can even tell if a data signal is good or bad. I mean, it's one thing to send the data, but how do you actually know if it's arriving nice and clean on the other side?
Well, they use a visual tool that creates something called an eye diagram. It's basically a health check for the signal. See the picture on the right? The big open space in the middle looks like an eye. That's a healthy signal. It means the ones and zeros are coming through loud and clear. Now look at the one on the left. It's a mess. The eye is all closed and fuzzy. That's a corrupted signal. Data is getting lost. So the main thing to remember is a wide open eye is good. It means the connection is solid. Okay, now that we know what to look for, let's see how this new system actually performed when they simulated some really bad weather. And honestly, the results are pretty amazing. First off, the speed. Each one of those 4 laser lanes was able to transmit data at a blistering 60 gigabytes per second. To give you some perspective, that's fast enough to download a full 4K movie in less than a second, on one channel. But here's the real proof. Check out this eye diagram. This is the signal for that 60 gigabit per second channel during a simulated heavy rainstorm. Look how wide open and clean that eye is. Even with terrible weather trying to mess it up, the data is just sailing through, clear as day. This is a huge deal. So let's just recap the big wins here. When you add up all 4 channels, you get a total speed of 240 gigabits per second. And it stayed stable over some really impressive distances, even in bad weather. We're talking 18 kilometers through heavy haze and almost 6 kilometers in a heavy downpour. And to be clear, this isn't just a small incremental improvement. When you compare these results to previous studies, you can see this system is a significant leap forward. It's pushing the boundaries for what we thought was possible with FSO, extending the usable range in both light and heavy rain. Okay, so cool numbers, cool tech, but what does all this mean for the real world? Why should you and I actually care about this particular laser setup?
Well, the big takeaway is all about reliability.
By proving that these laser links can be dependable even when it's storming outside, the technology becomes a much more practical and realistic solution. It means we could start connecting buildings and cities quickly and cheaply, and maybe, just maybe, finally solve that expensive last-mile problem for good.
You know, this research makes it seem like the answer is getting a lot closer to yes. By figuring out how to beat the weather, these laser beams might just be the thing that finally delivers fiber optic speeds to all of us without having to dig up a single street.